All right. Good evening, everybody. So just a quick show of hands. How many of you like dabble around with Python? Okay, good. That's most of the room, so that's good. I have a good audience. Okay, so today I'll be talking about Python code smells. So I guess I should first start off with what is a code smell. Okay, no, in fact, I'll start with clean code. Yeah, I only finished the slides quite late, so forgive me. Okay, so what is clean code? So clean code is a very long checklist of things to do. So you can see it must be readable, consistent, focused, so on and so forth. So actually, ChatGPT helped generate this for me. It's really helpful. But I guess here's where like the line between like art and science kind of crosses. So clean code, there is no one fixed definition. I would say clean code is something where if you kind of see, you know it. It's code that's kind of joyful to read. It's very obvious. And most importantly, right? So of all of this, I'll say the most important thing is that it should be easily maintainable. Again, it is like when you see code, it reads like English. It is very obvious what it does. It doesn't lie. And because of that, it's kind of fun to read and it's also fun to work with. And I'm pretty sure if you have kind of worked long enough, you have worked on very badly written code bases, and those are the times where I hate my job. But it is the times where I get jumped into a clean code base, or I go home and I work on a side project and everything's kind of where it's supposed to be. And that's very comforting. And that brings me joy in programming. So I guess we'll be looking at how is it that your code can become from dirty to clean, how to refactor code. And then I'll be talking about, initially, as I said, what is a code smell? Okay, so code smell, by definition, is a surface level indicator that that a piece of code has problems with maintainability. Okay, so let me quickly show you an example of very badly written code. As you can see, this code is very difficult to maintain because things are not really named properly. So let's start at the beginning. So for FQ and query filters, it's not clear what FQ actually means, and then afterwards, you know, there's that you can see like at the bottom, the code kind of like falls off because it keeps indenting and indenting and indenting, and then it's difficult for you as a programmer to kind of keep track, okay, what are the conditions that are going on over here? What are the ifs that must be fulfilled before this particular assignment is done or this particular code is run? And that makes it a bit difficult for you, again, if you're asked to work on this code base. If you need to refactor or you need to implement a new feature, it will be extremely difficult. So I guess code smell, again, there is no, it's more of an art. There's no science to it. So it's kind of when you see code like this and you go, okay, something's wrong. This needs to be cleaned up. So that's a code smell. Okay, so I think the best way to understand what clean code is to go through a very quick refactoring exercise to look at what dirty code looks like and the kind of different implementations and tricks and traits I've learned across the years of programming that you can use to clean up your code base. So let's look at a very ugly example over here. So this is a function you're given. It says get HOF and GT users, and it takes in a users object. And it initializes a list of 2 users, and then it goes for you and users, and then it does a couple of things over here. So off the bat, I would say, okay, so one of the drawbacks of Python as a language is that it is, and this is one of the good things also, is that it is a weakly typed language, which means that over here, when we look at this function, we're not sure what users actually look like as an object. We're also not sure, for example, this HOF users is a list, but it's a list of what? It's not very clear from this code, which is why the first rule of thumb, which I always have when you deal with, when you write Python code, is to always type your code. So you can use the typing module for this. And when you type your code, it looks something like this. So it's quite clear on what's going on, where this function takes in a list of dictionaries and it will return a list of integers. Sorry, a tuple of a list of integers and a list of integers. Reason why you want to do this, again, is so that as you are progressing down your code, you are quite clear what this, what users is. It's a dictionary. And you know that there are certain, a list of dictionaries, and you know that as a list, there are certain methods that I can apply to this, which I can't apply to, for example, a string. I know that, for example, I can loop over this, and if I were to do something like users dot, if I were to do some kind of string method on users, my editor will tell me that, hey, you're doing something wrong. You have typed in the beginning that this is a list of dictionary, but you're treating it as a string. So it's very helpful to kind of get your editor to do half the work for you, and it pays in dividends, I guess. Okay, so the next rule of thumb is to avoid abbreviations. So from this code, it's not clear what HOF and GT users are. And then it's also not clear what U for, over here there's a loop, right? For you and users. What I recommend is do not be lazy. Write your code, kind of name your variables properly for user and users, because it's not clear as you go down and you read the code. You have to remember what U actually stands for. Again, when you write code, you want to text yourself as little as possible so that the code flows like English. So if you were to type the code, it looks something like this. So now it becomes a bit clearer what this code is supposed to do. It's supposed to get Hall of Fame users and gold tier users. And it becomes a bit more obvious that, okay, probably these are criteria to see what kind of users they are. Are they Hall of Fame users or are they gold tier users? So yeah, second rule is try to avoid abbreviations. Third rule of thumb is that if your function contains the word and, it's probably a bad sign. If it returns a tuple, also that is probably a bad sign because it's violating the single responsibility principle. So what the single responsibility principle is that your function should be as small as possible and should do one thing and one thing only. So over here, it is getting two kinds of users. It's getting the Hall of Fame users and it's getting the gold tier users. You don't want your function to do that. You just want it to return Hall of Fame users, gold tier users, and then maybe somewhere else in your application, you'll be getting these two users and then doing something else with them. So this is how you kind of refactor it. So as you can see, the part which deals with the gold tier users is taken out. And we have something that looks slightly neater, I guess. Okay. Fourth rule of thumb, don't use magic numbers. So it's not clear over here what 100 actually means. I mean, it's quite clear because it says over here 100 is the criterion for Hall of Fame. But as far as possible, try not to write comments. Your code, as far as possible, should be self-commenting, which means that without the use of comments, I should be able to see what is it that you're trying to do. Why is it that you're writing this in this certain way? So 100, you can see that there's some significance to this value. And this should be refactored out into a constant that it's outside of this function. So as you can see, a criteria is being passed in as an argument within this function, and it's being defined up here. So typically in a larger project, you will put these in, let's say, a constants.py, and then you import them. Reason why is because it's, let's say further down the line, the business wants you to change your Hall of Fame criteria. All you need to do is just go to the top of the file or go to your constants.py and change. Versus you having to go into this function, look for the particular function, find the magic number, and change it. It makes code a bit less maintainable. So it's always cleaner to have something that, for constants especially, to have it defined very clearly what it's supposed to contain. Okay, number 5, your code should be self-commenting. So as you can see over here, since we have quite clearly stated that this is a criterion, we don't really need this comment over here. So we can kind of remove it. Okay, and it looks something like this, I guess. Rule number 7 is to avoid nesting code by using early termination. So if, I think it's the Linux Foundation, Linus Torvalds, he, hang on, let me think of what it is. He has a style guide for the Linux kernel. And one of the style guides, it's written in C, is that you should indent indentation should be 8 lines instead of 4 lines. And the reason why is that it forces people to indent as little as possible, because indentation is messy. You kind of, again, remember the first example I showed you, you kind of have to remember like the conditions. Okay, this must happen, then this must happen, then this must happen, then something is being done. Which is why it's always nicer and prettier to have, to terminate early. So example of the early termination is, okay, so let me jump into the code. If users.get users ID is not none, then do something. If kill streak is not none, do something. If this, then do something. You should terminate early. So it will look something like this, where if users get user ID is none, then you continue because you're not going to do anything. If the kill streak is none, you're not going to do anything, so you continue. So by, you can see how it's slightly more readable than having to, again, hold these conditions in your head as you write the code. Okay. Number 8 is to use white spaces to group logical statements together to improve readability. As I mentioned earlier, good code should read like English. It should read like you're reading an essay. And good essays, typically, they'll split things into logical blocks, paragraphs. And the same thing should be done for code. So for any logical block that you have, you should kind of split it up with white space to show, okay, this is one thing we're doing, then we're going to do this other thing, then we're going to do this other thing, and then finally we're going to return or append or do something. Okay. Rule of thumb number 9, ensure that your function does what it says it does. So again, when it comes to maintainability, when I see a function that says get something, I expect it to return that something. I don't expect it to get that something and then maybe print some other thing, or I don't expect it to have some kind of side effect. I expect it to do what it does and say what it does. So previously it was get Hall of Fame users, but it's actually not getting Hall of Fame users because it's actually returning a list of IDs. So it should be refactored to get Hall of Fame user IDs. Okay. Number 10 is to simplify. So yeah, I guess just slightly refactored. Rule number 11 is to reuse code. So you realize that this code is very specific to getting Hall of Fame user IDs, but it shouldn't really be. It should just be kind of filtering by kill streak criterion. And it feels like this implementation over here is a bit too specific, and you can refactor this by kind of generalizing the use cases. So as you can see, is user within kill streak, and then after that, the get Hall of Fame user IDs would just implement this function in a very straightforward way. Same thing for the gold tier users. Yeah. And last of all, I'll highly recommend using auto formatter. So the auto formatter which I use for Python is Black. And the reason why I use it is actually that there's no good reason. It's because it's popular. It formats code in a consistent way. And a big reason why I'm a big fan of auto formatters is because everybody has different styles of writing Python or writing their code. And auto formatter helps to ensure that everybody, at the end of the day, their code will look the same. In the sense that, okay, if your code runs across over certain lines, the formatter would kind of format it to a certain format. And it makes code reviews easier. It makes reading the code of your peers easier, which is always helpful in kind of surfacing any bugs that might happen. Okay, so this is with an auto formatter. You can see it's quite nice. And also, auto formatter helps to make code a bit more readable because it's a pet peeve of mine, but I dislike it when code kind of runs, like it just keeps running and running and running until it hits the end of the screen and then it runs some more. And I guess Black, what they do is that they format it to like 80 spaces. And fun fact, there's actually an interesting story of why it's 80 spaces. Is because in the past, programming was done in like those little, the cards, and the cards had, I think 72 punch holes. And then 8 was for like the programmer, so it's 80. And that is a tradition that kind of kept up with auto formatters. But it's nice, I guess, having code that it's kind of short and concise, like you're reading a newspaper or a magazine rather than reading a dissertation. Okay, so let me finally talk about refactoring and beyond, and a little pet peeve I have about dictionaries in Python. So fun fact, I actually try my best not to use dictionaries in Python. I don't like that data structure. Okay, no, sorry. I messed up my slides again. So let me talk about a bit about dictionaries and things that you have to be aware of when you use dictionaries. So let me go through a very simple example. So over here you have, I guess like 4 functions. It's very simple. So first with get user, it'll return a user ID mapped to 1, get user score. And then the third function is get user of user score. So all this function, and today we'll be looking at this function over here. And what we want to do is simply just join these 2 dictionaries together and return it. Very simple. And there are actually a few ways of doing it. So this is one way, which is that you take in use the dictionary, you take in the user score dictionary, and then in the user dictionary, you initialize a key, and then you assign it to score, the user score over here, and then you return it. Another way you could do it is by doing something like that if you want to be a bit more safe, in case you're not sure if there's anything inside user score. Another way you can do it is by doing this, but all of them has its own drawbacks. Can anybody kind of point out what's wrong with the 3 methods that I showed over here? Go for it. Sorry?
Error. What's the tool?
Sorry. I see. Oh, there's an error inside. That's not my intention actually. Oops. Okay, no. So yeah, but thank you very much for trying to find it out. So yeah, go for it. Okay, so let me use this example instead. This one. So it's quite clear that if this score doesn't exist, then it'll be none, and then none will be assigned to the key score. Right, go for it. No, but that's a good point. I'll get to it later. It's part of my presentation. Okay, so let me tell you what's wrong with this code. The problem is that this function is actually impure, which means that over here, this user data is being changed, which means that later on, if, okay, let me kind of show you what happens. So let's say you are over here and you, okay, over here. So user, you get user, and then after that user is user score, right? So over here, this user has now changed state with this function. And if further down this this main function, you were to use user, the data has changed, and so you are dealing with like a changed state, and you're not, and that's why you have to be very, very careful with the way you are kind of dealing with state in your functions. Okay, so the proper way of doing this is to write pure functions. So again, a pure function means that it's a function that does not impact external state. And how people would typically do it is by doing something like this, which is that you create a copy of the original user dictionary, and then you assign it. Another way is also to initialize a new dictionary and then kind of do the assignment manually. Although, yeah, something like this if you want to be a bit more terse. But my preferred way is this, with this syntax, which is, I think it's a bit new with Python. So it's dictionary unpacking, which is that we initialize the dictionary, we put dictionaries inside, and then we unpack it. So this now becomes a pure function. If I were further down over here, let's say I'm here, my user and user score objects do not change state because the function that deals with them is pure. And I say this from experience because I have dealt with impure functions before, and it's a huge headache to debug because the functions themselves look very innocuous, but it's actually doing something unexpected. Sure, go for it. Yeah. Just to clarify, are you saying that some languages there's the it copies the value versus copies like the reference to the object, something like that? Yeah, that's right. So correct. Precisely. So what it says that whenever you change stuff, you should always try and change a new variable or copy of the variable so that you don't accidentally change the original copy. And yeah, that's exactly what pure functions is supposed to do. Because again, if you mess with state, you're going to have a very, very bad time down the road. Okay. So yeah, the takeaway is just beware of impure functions. Okay. So the second code smell, I guess, is kind of like defining default values manually. I've kind of seen this before, where people just they just plug in the default values inside, which makes it kind of I don't really like it when people write code like this or like this. Yeah, because there are better things than dictionaries, which I'll go through shortly. Okay, so this is a problem with dictionaries, is that it's an opaque data structure. I can say that, okay, this object is a dictionary, but that's all you get. You don't know what keys it has. You don't know what values it has. You don't know if it's a dictionary nested in the dictionary. And it makes it a bit frustrating because all you get is this object is a dictionary, and that's it. Other languages, strongly typed languages kind of deal with this problem with their own implementations. So in C and Golang, you have structs. So you have an object and it looks like this, and it's going to be like this. So in TypeScript, you have interfaces, and in Java, you have classes. So in Python, there's also a way to kind of describe your data structure. And surprise, surprise, it's a class. So a class will help to describe how is it that your object looks like. So again, you have a poker card over here, and I initialize the poker card. So it's very clear that this poker card has value of 8, suit H. And yeah, it makes things, all you need to do is kind of like go over here. You hover over poker card class, and it tells you, okay, this object has 2 attributes, value and suit. Of course, the problem about this is that if you ever try to print this poker card class, what you get is a very unhelpful memory pointer. So it just gives you like a bunch of, I remember the first time I did it, it looks like a bunch of gibberish. I'm not sure what to do with it. Reason is because you need to, I guess classes is just a very lightweight implementation. You need to implement a string method yourself to say, okay, if I were to print this particular object, what is going to show on my terminal? Okay, and that's where you have to kind of write this yourself. Okay, return self.value of self.suit. So from here, you will get, if you print this object, you will get 8 of H. And maybe if you want to have a few poker cards and you want to compare them with each other, you have to implement your own equality check. So if I were to initialize 2 cards that are different and then try and, 2 cards that are the same value and suit, and then I try and compare them together, I will need to implement this equals method to ensure that the correct value is actually shown, that these 2 cards are actually equal to each other. So is there a better way of doing things? Yes, there is. Is this thing called data classes? I think it was implemented in Python 3.7. That kind of takes away all the boilerplate code that classes have. So whatever implementation you saw just now is kind of simplified. So with that, you have this simplified into this. So you can just describe, okay, data class, and this is how my object would look like. And you get all the typing that comes with it. The problem with data classes is that it is not, it does not enforce type. So for example, I could do something like this, and it will be absolutely valid. I could say that value is an integer in my data class description, but I actually pass in value as a string. And Python will not raise an error to me, which is a problem because later on, as I were to do work, I realized that, hey, I thought I was dealing with an integer, but I'm actually dealing with a string. one way of and on top of it, right? This is how you kind of implement type checking. And as you can see, it's quite tedious because you need to implement your own type checking to check if the instance of the value that's inside of a value that's inside the suit is correct. If not, you have to raise your own exception. Thankfully, there are libraries that does this for you. So today I'm going to talk about a library called Pydantic. And what it does is that it type enforces whatever that goes into your class. So for example, if I were to do this, value 8, it's supposed to be integer, but it's a string. What happens is that Pydantic raises the error for me. It tells me that you are doing something wrong. You should go and check if what you're doing is correct or not. Okay, so this is a comparison of the different data structures I went through. So you have the classic dictionary, you have the class, where you can kind of like hint, you can type hint. Also, you can define default values. Data classes, which is slightly nicer because there's a bit more support and it helps to write some of the boilerplate methods they might have. And then finally, there's Pydantic, which it's not part of the Python standard library. So you're gonna pip install, but then it gives you all of these very nice and very fancy things. Of course, each of them has their use cases and drawbacks. So for example, Pydantic, obviously, if you're because it helps you to type check, it's going to be a bit more heavy as a library versus, let's say, using a data class or a class. And yeah, so instead of defining values manually like this, you can always write a class and then you can just initialize it with, okay, user is going to be, you're going to initialize it with a certain value unless an argument is passed in with default arguments. And I guess, this is kind of a decision tree that I have on when is it that you should be using each of them. So if you need, if there's something that needs validation, you pass it through a Pydantic-based model. If something needs immutability and structure, then you pass it. Sorry, if it doesn't need immutability and structure, then it becomes a dictionary. If you need modular control, then use a Python class. If you don't, data class. But the rule of thumb that I have for picking which tool to use is quite simple. If you're not sure about what data is coming in, for example, you make some kind of external API call that comes into your system, you don't know what's coming in. Tomorrow, the API might change, and that might break your entire system. That's where you need to guarantee what's coming into your system, and that's where you use Pydantic-based models. If you're within your own system, and you already know, okay, from this API, this particular object of this structure is coming inside, and I need to return an object or a dictionary or whatever, I can use a Python data class to kind of describe the schema of what kind of objects my function is trying to return. If, for example, I want to make a very quick hash map, then I'll be using a dictionary. And honestly, I never really found the use of like Python classes. I don't know, I could be a bad programmer. But yeah, so this is the decision tree that I usually go through. And that's usually my thought process on how is it that I decide which of the libraries to use. Yeah, and yeah, just as a I'll send these slides on the channel, and these are a few references which I highly recommend everybody to read. So first is Clean Code by Uncle Bob. So highly recommend. PEP 8, Solid Principle, so on and so forth. And yeah, that's about it. Take care, everybody.
Questions?
Go for it.
I'm wondering about certain things. Is it okay to like use a lot of like the what called a list comprehension?
Oh yeah, it's normal to use this comprehension. In fact, that's my default way of kind of looping through things. In fact, it's a very Pythonic way of doing things, and it's yeah. So I guess I hope that answers the question. Yeah.
To add on, right? Pydantic actually can
Sorry, but Pydantic is actually can be used for LLM capabilities as well. So you can use it to do prompt engineering for that as well. So you can use Pydantic to check whether your response is the correct one or is there any hallucination for it as well lah. So that's why a lot of people was pushing for Pydantic as well. That's the reason it's popular.
Right.
Thank you.